We saw in Chapter 3 how to calculate the optimal bundle for a consumer, Q1, Q2, given the prices P1, P2, and the consumer's income Y. So if Q1, Q2 is the optimal bundle at those prices and that income, then the demand for good 1 is Q1. So that's the demand for good 1 as a function of price P1, P2, and income Y. Similarly, Q2 is the demand for good 2. Of course, to draw the demand curve, what we're going to do is to fix the price of good 2, fix the income, and just find the quantity of good 1 as a function only of the price of good 1. So we're going to do this for some particular utility functions, just as an exercise. We'll start with perfect complements, then we'll do Cobb-Douglas, perfect substitutes, quasilinear, and then we'll actually look at CES utility. So let's start with perfect complements. Remember, the perfect complements utility function is utility from Q1, Q2 is the minimum of Q1 and Q2. So what you do is that you would purchase the goods in equal quantities. So you'd buy essentially a combined good, a composite good that is comprised of, for every unit of good 1 is comprised of also a unit of good 2. So you wouldn't buy different numbers of left and right shoes, right? So you'd only buy the same number of left and right shoes. So the price of the combined good is just P1 plus P2. So if you want to buy 1 unit of the combined good, which includes 1 unit of each of the 2 goods, it's going to cost you P1 plus P2 per unit of this combined good. So if you spend all of your income on that combined good, how many units could you buy? Well, you've got Y dollars, and if you spent Y dollars on these goods that cost P1 plus P2, in total you can buy Y divided by P1 plus P2 units of it. So if you're buying a combined good that is comprised, if you're buying Y divided by P1 plus P2 units of this combined good, then you're buying that many units of the first good and the same number of units of the second good. So your demand for the first good as a function of P1, P2, and Y is just Y divided by P1 plus P2. So now if I want to draw your demand curve, how am I going to do that? Your demand curve for good 1. Well, I need to know what P2 and Y are. So what we're going to do is we're going to fix them. So let's suppose P2 is 3 and Y is 9. Well, I'm just going to plug those in to the formula on the previous slide. So instead of Y divided by P1 plus P2, you get 9 divided by P1 plus 3. And if we were to plot that, it would look something like this. As the price of good 1 increases, you're going to buy less of it. And when it goes to 0, you're not going to buy an infinite amount of it. When P1 goes to 0, you're going to buy 9 divided by 3, which is 3 units of it. That's because you can only afford to buy, even if let's say good 1 was right shoes, you can only afford to buy, even if right shoes were free, you can only afford to buy 3 left shoes, so you'd only buy 3 right shoes. Next, we look at Cobb-Douglas utility. Remember, the Cobb-Douglas utility function is one where the utility from Q1, Q2 is Q1 to the A, Q2 to the 1 minus A, for some constant A. For some constant A. And remember, we solved this last time, so we won't redo it, but when your income is Y and the price of goods 1 and 2 are P1 and P2, then your demand for good 1 is going to be AY divided by P1, and your demand for good 2 is going to be 1 minus A times Y divided by P2. So what does your demand curve look like if you have Cobb-Douglas utility? Again, we're going to fix the price of good 2 and we're going to fix the income, so we have the following demand curve. Let's suppose A were a quarter, Y were 10, then your demand for good 1 would be 2.5 divided by P1. So if we plotted that, we would get a curve that looks something like this. Next, we look at perfect substitutes. Perfect substitutes utility function says your utility from Q1, Q2 is just Q1 plus Q2. If both the goods have the same price, then you buy whatever bundle. It doesn't really matter. So just let's go back to our intuition here. Instead of trying to write down the optimization function, trying to use calculus, just use our intuition that if all I care about is the total number of units that I consume, and both goods cost the same, then it doesn't really matter which of the two I buy. I'm just going to spend all my money on buying some of either of these goods. However, if one of the two is cheaper than the other, then I'm just going to buy the cheaper of the two. So if P1 equals P2 equals some number P, then the demands are such that my demand for good 1 plus my demand for good 2 has to just equal the total amount of the two goods that I'm going to buy, which is I'm going to spend all my money on buying these goods, each of which costs P. So in total, I can buy Y divided by P. However, if P1 is lower than P2, then I'm only going to buy good 1. So I'm going to spend all my money on good 1. I'm not going to buy any of good 2. On the other hand, if good 1 is greater than good 2, so if the price of good 1 is greater than the price of good 2, then I'm only going to buy good 2, and I'm not going to buy any of good 1. So what does my demand curve look like? Again, we have to fix P2, and we have to fix Y. So let's suppose we fix P2 at 3 and income at 12. Then the demand for good 1 is if the price of good 1 is the same as the price of good 2, which is 3, then I'm going to demand any quantity between 0 and 12 divided by P1. Remember, Y is 12, and P1 is 3 in this case. So I can demand either 0 units of it, or I could spend all my money on good 1, or anything in between. However, if P1 is higher than 3, if the good 1 is more expensive than good 2, then I'm not going to buy any of good 1. But if good 1 is cheaper than good 2, then I'm only going to buy good 1. I'm going to spend all my money. I have $12. I spend all $12 in good 1, and I can afford 12 divided by P1 units of it. So what does this demand curve look like? It looks like that. At the price P1 equals P2 equals 3, I can demand any quantity between 0 and 12 divided by P1, which is 4. At any price higher than P2, which is 3, I'm going to demand 0 units. At any price lower than 3, I'm going to follow this part of the demand curve, which just says spend all your money on good 1. Next, quasi-linear preferences. The demand function is going to depend on the particular form of the utility function. In this particular example, we have a square root of q1. Remember, quasi-linear utility is of the form u of q1 plus q2. So the demand function is going to depend on what this u of q1 is. In this particular case, u of q1 is some constant a times the square root of q1. There are going to be two cases here. And those two cases are where you have an interior solution and a corner solution. And we saw this from the last chapter. Let's work this out so that we understand better what those two cases are. If you want to maximize this function with respect to your choice of q1 and q2, you're going to solve this maximization problem. Subject to the constraint that P1 Q1 plus P2 Q2 equals Y. What we're going to do is we're going to solve this for Q2 and substitute to eliminate one of the variables. So if we solve this for solving for Q2 equals y divided by P2 minus P1 over P2 times Q1. So we can just go in and replace this guy and make this into a single variable optimization problem. P1 over P2 times Q1. And then we don't have to worry about this constraint anymore. Okay, so if we want to solve this, now we can write down the first order condition. We just take the derivative of this with respect to Q1. The derivative of that, the first order condition, is 1/2 A times 1 over square root of Q1. The derivative of y divided by P2 with respect to Q1 is 0, and the derivative of minus P1 over P2 times Q1 is just minus P1 over P2. We're going to set that equal to 0. That's the first order condition. Now we're going to solve for Q1. So solving for Q1, we find that Q1 equals A times P2 divided by 2 times P1 squared. Now that we have this, we can go back and find Q2. Remember, Q2 is y divided by P2 minus P1 over P2 times Q1. So that's going to be y divided by P2 minus P1 over P2 times, we're going to plug this guy in here. So it's a squared divided by 4. I'm going to split it up into two parts. P2 divided by P1 times P2 divided by P1. So we've got the P2 squared, which is just P2 times P2, P1 squared, which is P1 times P1. Now, this P1 and this P1 will cancel out. P2 and this P2 cancel out. So we've got y divided by P2 minus a squared over 4 P2 divided by P1. So that's Q2. When would we have an interior solution? This is always positive, right? This is always positive. That's never going to be a negative number because A, P2, P1, and 2 are all positive numbers. However, this might not be a positive number. What happens if y divided by P2 is less than a squared divided by 4 P2 over P1? In that case, in other words, suppose y is less than a squared divided by 4 times P2 squared divided by P1. Suppose your income is low compared to given the prices, then this thing is going to be negative, which doesn't make any sense. You can't consume a negative amount of the good. So we have to have a corner solution. In this case, the consumer consumes only good 2. In this case, the consumer is actually going to consume 0 units of good 2, and they're only going to consume good 1. On the other hand, if we had instead that y divided by P2 is at least as big as a squared over 4 times P2 over P1. In other words, if your income is relatively high, then we're going to have that Q2 that we found is non-negative. which means that this is good. This is a feasible point for this consumer to consume. So then we have an interior solution. So those are our two cases. So if we have an interior solution when the income is high enough, so when the income is at least a squared p2 squared divided by 4p1, in which case the consumer consumes these bundles. And we have a corner solution if the income is relatively low. Notice that when y is exactly equal to this, then the interior solution and the corner solution are equal, because this thing is going to be equal to 0. Again, we would be able to just plug in, if we wanted a demand curve for good 1, we could just plug in P2 and Y, and that would tell us what the demand function for good 1 would be. Similarly for the demand function for good 2. Next, we look at constant elasticity of substitution. We won't get into this in too much detail, but the constant elasticity of substitution utility function is such that there's some constant rho, and the utility function is q1 to the rho plus q2 to the rho, whole thing to the 1 over rho. And we're going to assume typically that rho is between 0 and 1, and if you let sigma be 1 over rho minus 1, then the demand functions take these forms. You're not really going to see this too much in this course, so don't worry too much about these.